Hello all, welcome to my YouTube channel. So in today's video we are going to discuss about providers and resources in Terraform. So let's start. So what is providers? A provider in Terraform is a plugin that enables interaction with an API. This includes cloud providers and software as a service providers. So basically a provider is nothing, it's just a plugins which basically interact with the cloud service or cloud providers in the backend. So for example, if you want to spin up your environment or resources in AWS, in that case AWS will be the provider. Similarly, if you want to spin up your resources in Azure, in that case Azure will be the providers. So these providers configuration you have to specify in the Terraform configuration file, so Terraform knows, okay, I need to interact with AWS provider or Azure provider based on the configurations. So for example, let me open my Visual Studio Core editor. So here I have very simple configuration files where basically I'm going to create a EC2 instance on AWS. So you can see here in the provider block, basically we are specifying provider type as a AWS. So similarly, if you want Azure, you can provide the provider type Azure. So what it does, it basically when you run the Terraform init command, it will download the plugin for AWS. We will see in coming slides. So if you can see, as of now we don't have any files or folders here. So let me go back to my PPT. So I hope you got it. What's the role of providers in Terraform? So initialization phase. After writing your Terraform code or cloning your existing Terraform code from source control, the Terraform init command is the first command you should use to initialize the working directory. So the Terraform init command performs the following steps: backend initialization, child module installation, plugin installation. So if you see here, it's first what it is doing initializing the backend, so working directory, basically it's initializing. Similarly, if you know, like when we do any operation in Git, first we do the git init, so basically initialize the working directory. So same concept we can see here also, like initialization phase, first it will initialize the working directory. So the first step is initializing the backend. Next, initializing provider plugins. If you have any modules in your Terraform configuration file, then it will also download the modules for you. So if I'll go back again to my configuration file, I don't have any modules, I have only providers. So what it does, when I run the Terraform init command, it will download the provider plugin. So let me run it. Okay, spelling mistake. So now you can see it's initializing the backend. Let me move up. So initializing the backend, then initializing the provider plugin. So you can see it automatically create the .terraform directory. If I go back to this particular directory, let's finish this operation complete. So basically installing HashiCorp AWS plugin. So the version you can see 4.56.0. So it's basically downloading the latest plugins. So you can also specify the specific version which you want. So now you can see Terraform has been successfully initialized, and also we can see it's created two files, one folder and one file. The file is .terraform.log.scl. We will discuss about this file in coming slides. And this particular folder .terraform. So let me open this folder in the file explorer. So I'll go back to my desktop. So we have a fruit folder here, resources and providers. Now you can see it's created the .terraform folders. Now in .terraform folder we have one folder called providers, which is this one. And if you have any modules, it will create a folder called module also. So if I'll go back to my provider folder, so this is the URL of Terraform registry. So this is the plugin, basically its download. So now this plugin basically interact with the AWS to create the resources for you. Now I'll go back to my slide. So I hope you got it, the initialization phase. Now another thing, if I'll go back to here, now it also created .terraform.log.scl file. So let's see what's the purpose of this file here. So once provider have been successfully installed, Terraform create a dependency log file and write information about the provider to it. This file will be named .terraform.log.scl and should ideally be committed to a repository in your version control system to ensure that the same provider version are used when Terraform init is run again in the future. So basically in this file, the purpose of this file, it writes the information about the providers. Like in our case, we have downloaded the provider AWS. So it's write all the information about AWS provider, like what version you have used. So the ideal practice is you have to check in this particular file in your source control. So whenever another person also will run this particular Terraform init command, so it know, okay, this the particular version, like in our case 4.56.0. So this version should be used across the operation or across, like, creating the resources for using this particular Terraform block. So if I'll go back to my VS Code editor, so let me see what's inside this particular file. So you can see this is the provider, this is the URL of Terraform registry, then we have HashiCorp, then we have AWS. Now here we have versions 4.5.56.0. These are the hashes. This should be unique for each and every version and each and every providers. So it's basically write down all the information about the provider plugin. So for coming future, if somebody else want to use this particular configuration files which you have written, they will know, okay, this is the version we have to use. So it's recommended you should not touch or modify this particular file. So I hope you got the point, like what's the use of .terraform.log.scl file. Now we have .terraform directory, so which we have already discussed. Like Terraform use the .terraform directory to store the projects, providers and modules. Terraform will refer to these components when you run validate, plan and apply commands. Terraform automatically manages .terraform and do not directly modify this directory's content. So you should not touch this particular folder .terraform because this is completely managed by Terraform. So for this particular slides, we have two folders called modules and providers. But if I'll go back to my file explorer, we have only one folder called providers because we don't have any modules in our configuration file. So I have not specified any modules here. If you have any modules, then those modules will be downloaded under this module directory here. So basically we should not play with these files. Now another important part is here resources. So resources are the most important element in the Terraform language. Each resource block describes one or more infrastructure objects such as virtual network component, compute instances or high level component such as DNS record, load balancer and etc. So if you see in this particular resource block, this is called a resource block. So here resource type we have specified AWS_instance and this is the local name BAB. So Terraform knows, okay, I need to create a AWS instance as part of the AWS provider. And if you see these are the attributes, AMI, ID, instance, these are the attributes of this particular AWS instance type. So resource syntax, basically resource are defined through resource block. In this example, immediately following the resource keyword is the resource type. So AWS_instance is the resource type, which in this example is AWS instance. The following is the local name of the resource, which is in this example is BAP. So this is the local name of this particular resource type. This local name can be used to reference the resource in the code in the same module. Both the combination of type and local name must be unique in the current module. So if you're using this particular module, then the resource name and resource type should be unique. If you have different type of resources, like for example, instead of AWS underscore instance type, you have another resource called IAM underscore user, then the resource name you can specify the local name Bab also. But if you specify, if you use multiple resource, like if you have another block resource called AWS underscore instance, then you cannot keep the same local name. So if you have to keep same local name, then the resource type, it in this example AWS underscore instance, should be different. So here you can see the local name can be used to reference the resource in the code in the same module, but the combination of type and the local name must be unique in the current module, and the local name of two resources of different type can be same. So if you have different type of resources, then you can keep the same local name. If you have same type of resource type, then you cannot keep the same local name for both the resource type. So I hope you got my point here. And next we have comes to configuration block. These curly braces, whatever you are writing, this is called the configuration block basically. So within the block body, between curly braces are the configuration argument for the resource itself. So these are the resource elements or attributes for this particular resource type, which is AWS underscore instance. So most argument in this section depend on the resource type, and indeed in this example both AMI and instance underscore type are argument defined specifically for the AWS underscore instance type resources. So if I'll go back to my browser here. Okay, let me open Chrome. So if I'll go back to terraform.io, I'll go to registry. I'll browse the provider. So in for this case, I'll choose AWS provider because we have configuration for AWS. If I'll go back to documentation, now here I will search for EC2. So these all are the services basically. Okay. So here we have EC2. So now you can see under this particular issue, these are the like AWS underscore AMI, AWS underscore AMI copy. These are the sub resources basically. There is no one-to-one mapping, but these are the attributes which we can use. So if I'll go back to AWS instance, now under AWS instance, if I'll go down, so you can see arguments reference. So the following arguments or attributes you can use as part of AWS instance creations. So there are many which is optional, and there are few which basically required. So for example, if I'll go to AMI instance, sorry, AMI type, okay, it should be top. Okay, let me see which is not optional here. So these are all the optionals. Like if you don't specify also, it will automatically create it for you if it's required for that particular resources. So these all are the optional basically. Okay, let me search for instance type. So you can see instance underscore type is required. It's not optional, so you have to specify. So whatever the required for creating the EC2 instance, that you have to specify in the configuration. So I'll go back to my VS Code editor. So we have seen initialization phase. Now the next part is Terraform apply. So now you can see whatever the required attributes we have, it will automatically take here. So if I'll go back to AMI ID, so we have already specified AMI type, so it's already taken. And similarly for instance types t2.small. So when I run the Terraform apply command, so you can see we have specified only two things here. So now I will run Terraform apply command. Okay, so now it's creating the EC2 instance. Now once it creates the instance, you can see a lot of other things, other values you can see for this particular instance, but we have not specified any optional things. We have only specified the required one. So let's wait to finish this AWS instance creating process. Now it's basically instance creation is completed. If I'll go back to my browser, so now we can see t2.small is an instance type. It's created the instance for us. So now if I'll go back to my VS Code editor, now you can see it's also create a file called terraform.tf state. So we will discuss this particular file type, about this file in a coming video, but let me show you what we have inside this particular file. So you can see AMI ID we have, and another thing, availability zone, it's automatically taken, CPU credits. So a lot of other things you can see here, IDs, instance type we have already specified t2.small. So a lot of other things basically it's created for us. If I go back to the public IP address, but you can see that this is the public IP address 13.232. If I'll go back to my console here, now if I'll go to networking, okay, so this is the public IP address 13.232. If I'll go back 13.230, so but we have not specified these things, it's automatically came up in this particular file. So we will discuss in coming videos about the purpose of this particular terraform.tf state files. So I hope in this video you got to know like what's the purpose of resources and the providers in Terraform. So that's all for today. See you in next video. Thank you so much.